what you put into your calculator. Making sure you got a 0 there in place of your y. And then you're going to somehow communicate to me that you're going to use your RREF feature of your calculator. And out is going to come something. If it's bad, I have no idea what it's going to be. But if it's bad, then remember we have our math prep option. Because we aren't going to be putting all of those decimals in there. I got decimals, did you? So I press my math, enter, enter, and up come, I mean, they're not nice fractions, but at least I don't need to round them off. So the matrix comes out, it's 219/95, negative 94/95, and negative 4/95. So then I write down the answer to the question, which is those numbers right there. And no complaining about what you're writing down. Remember, you did nothing. You did no work at all. So at least you can write it down. All right, how does that look to everybody? Okay? All right. Chase, you got it?
Yeah.
All right. Next question, there's only going to be 2. One of them's going to be this. And the other one is going to be a Kramer's rule problem. All right? So 2x plus 5y equals 7, negative 3x minus 4y equals 2. The directions are going to say solve using Kramer's rule. Who remembers how that works? Find the determinant of the x's and the y's. So 2, 5, negative 3, negative 4. These are the x's, these are the y's. And when we do this determinant, you guys, it's always done exactly the same way, so learn the procedure. We start right here. So 2 times negative 4 is negative 8. We're multiplying. Negative 3 times 5 is negative 15. But then what do I do with those 2 numbers? Minus, that's right. It's this one minus this one. So that actually works out to be 7. And then where does the 7 end up in terms of the answer? The denominator of x and y. So remember, you are looking for x and y. In the last problem, we were looking for x, y, and z. Now we're just looking for x and y. And that 7 is the denominator. Now, what's the numerator? To find the x numerator, I make another determinant. And how do I do that? I take these guys right here and put it right here. That's x. So 7, 2, If not, you just leave it alone. Got it? So, wrong time till Monday. No, Monday, or Tuesday, sorry, Tuesday. You're gonna bring something round, edible, or shareable, and you're gonna be prepared for these two questions. Okay? Alright, let's get our notes out now. Let's take a look at these wild and wacky. Now, everything you see set up here on the page is what will be set up. This is 7.5. Number one. And you will have all of this set up for you on testing. There will be one problem like this on your test, which will be shortly after spring break. Let's see if we can figure this out. First thing you do is read through the problem and find a place in your chart for every number. And so every number in the problem has a place in the chart. Now, some of the spaces might be empty, and that's okay. You just gotta make sure you have every number in here. All right, so here we go. You are taking a test in which items of type A are worth 10 points. All right, where is the 10 going to go? Value of A, right here. In the value A spot. Items of type B are worth 15 points. Takes 3 minutes for a type A. And 6 minutes for a type B. The total time allowed is 60 minutes. You may not answer more than 16 questions. Total number, 16. Everybody still with me? Assuming all of your answers are correct, how many items of each type should you answer to get the best score? So isn't this what we're looking for? The number of A's and the number of B's? So let's call that X and Y. Normally, don't we call X what we're looking for? So I'm going to call one of them X and one of them Y. And my job is to get the maximum. Sometimes we will be minimizing, since we're preparing for that. I am maximizing my score. How is my score calculated? When I sit down and I take this test, how would I figure out my score? You're either sound asleep or you're way overthinking this. Every X I get right, I get how many points for? 10? So if I get one right, I get 10 points for that question?
Mhm.
What if I get 2 right? Yeah, so my score is calculated by 10x plus 15y. These are word problems, you guys, I can't feed them to you. You gotta think.
Is that the same as where it says expression to maximize, or is that something different?
No, that is the expression to maximize. I wanna maximize my score. Now, to help us answer the question, we have some guidelines. And you've already got them in your chart. For example, don't you know that x plus y has to be less than or equal to 16? Think about that for a minute. What's x? A questions. Y is B questions. And what do I know about the total questions I can do?
16.
Less than 16, right? Less than or equal to 16, no more than 16. So one of the constraints of the problem is right there. Another constraint of the problem is time. 3 x's and 6 y's have to add up to be less than or equal to 60, because that's all the time you got. Constraints are the things that hold you back. You can't, as much as you'd love to, you can't just keep on doing these problems for a week. You have 60 minutes. There are a couple of implied ones that you can, they're built right into the graph already, so you don't need to worry about them. But absolutely, x and y have to be positive. Would you agree with that statement, that x has to be bigger than 0? You cannot do negative questions. And that will be the case in almost every single one of our problems. They'll be implied. You don't have to list them if you don't want to, but it sure looks good if you do. Okay? All right. So now, we're gonna sketch this. So I'm gonna get my handy dandy blue marker, and I'm gonna draw a picture of this guy right here. That inequality. Now when you do this, you are going to have to make, extend your graph. It's fine, just extend it the best you can. When I sketch these, I always use intercepts. Here's what I mean. Instead of doing y equals mx plus b, which is going to get a little awkward with some of these problems, I cover up one letter. If I cover up x, then y is 16. 1, 2, 3, 4, 5, 6, 7. And I label that point. That is, if x is 0, y is 16. Then I'm going to cover up this guy and do the same thing. Well, if y is 0, x is also 16. And then I'm going to connect those with as straight a line as I can. And then I'm going to shade. Where do you think I'm going to shade? Huh? Less than, underneath. I'm shading underneath, right here. All this triangle is shaded. Now I'll get my red marker out, and I'm gonna do the same thing with this equation. So if I cover up x, what's y? 10. And if I cover up y, x is 20. Don't panic, don't complain, don't whine, just extend it. And then again, connect those with as straight a line as you can. And where is he shaded? Underneath. Now, we don't need to worry about these implied ones because by drawing the coordinate axes for you, I've automatically put in X and Y are both positive. See how I only do quadrant 1? Yeah, that's already taken care of, so you need to worry about those. We're done with the picture. Now you should see in there that you have a region that's both colors. Would you agree with that? That guy right there? That's called your feasible region, and the answer to the question is going to be one of these black dots. The vertices. Let's make a list of those. You got a black dot at 0, 10. You got a black dot at 0, 0. Got a black dot at 16, 0. And then I got a black dot kind of out here in the middle. Now we're not going to eyeball that. We're going to actually figure out where that black dot is. Okay? So, anybody have any idea how we will figure out where my blue line and my red line come together? What?
Did you plug them in? To have different equations?
Plug what in?
Like 0 and 10.
Okay, I'm trying to find this point right here. Yeah. I definitely use my two equations. Isn't that the point where these guys cross each other? Can't we substitute or eliminate or Kramer's rule to find that point? Yeah, so do whatever you want. I got my red line and my blue line. And I want to know where they cross. So you know me, I'm going to eliminate every time. So I'll multiply that one by -3. You can do it however you want, whatever works for you. I'm eliminating using elimination here. You can use Kramer's rule if you want, like to practice it. I got 12, 4. So that is my 4th point. Alright, so let me pause there for a minute, make sure everybody's keeping up. Once we got our constraints written, our equations written, we graphed them. Everything's going to be shaded somewhere. We look for where the shading overlaps. And then that shape, that feasible region, we find the corners. And if we know them already, that's great. If we don't, we might have to do a little work. One of those points is the answer. Now remember, what does this mean? 16, 0. That means X is 16, which means I did 16 type A questions and no B's. Well, what would my score be? If I did 16 A's and no B's, what would that be? 160, thank you. So my score, I'll put the score over here, is 160. What if I don't do any questions? 0. that point is not your maximum, it is your minimum. Your feasible region will always give you both. We want the maximum this time, so we want not bad, obviously. What if I did no X's or no A's and 10 B's? What would my score be there? 150. And what if I did 12 X's and 4 Y's? One what? 180, I think. Isn't that 180? Okay, what was our objective? Get the highest score we can get, right? So what are we gonna tell you, or whoever's doing this, we're gonna say, we should do, we're gonna write a sentence to wrap it up. We should do, and you do this in your own words, we should do 12 A questions and 4 B questions for a total of 180 points. So one of these on test day, but every piece of this has a point value, so you can see this one problem is worth a lot. Because there's just so much of it. All right. You good? I got a race to go on. So here we go. All right, so let's see, we got our little chart all set up for us this time. We got potatoes, corn, total. We got acres, seed cost, profit. Maximize and minimize something. All right, have you read the problem? Are you filling in your chart? What do I do with the 70?
Acres total.
What?
Acres total.
Acres total. I got 70 acres total. The seed for potatoes costs $20 an acre. What did I do with the 20
Seed cost
for potatoes? Corn is 60 an acre. The farmer has set aside $3,000 to spend on seed. Seed cost total. The profit per acre of potatoes is $150. Potato profit. Find the optimal solution for the farmer. What does that mean? What are we trying to do here? Maximize his profit. So we want to maximize his profit. And how are we going to do that? Well, how many acres of potatoes and corn am I planting? Isn't that the question? So what do you think I'm going to do? Call X potatoes and Y corn? And then my profit will be 150x plus 50y. Every acre is 150 of potatoes. Every acre is 50 corn. Now let's write our constraints. Which one equation you can get out of here?
X plus y is less than or equal to 7.
Very good. Very good. However many acres he plants, he can't plant more than 70, because that's all the ground he owns. All right, got another one?
20x plus 60y is greater than or equal to 3,000.
Less than or equal to 3,000. However much money he spends on potato seed and on corn seed, it has to add up to be less than 3,000, because that's all the money he has. We have our implied ones. We can't plant negative acres, so X and Y are both positive. But we built that into our graph already. So you ready to start sketching? Here we go. Here's my blue equation. Why don't we count by tens this time? Use a scale of 10. Does that work okay? So I'm gonna start by 10. So 1, 2, 3, 4, 5, 6, 7. Here's 70, comma 0. 1, 2, 3, 4, 5, 6. Here's 0, comma 70. So I'm letting X be 0, Y then is 70. I'm letting Y be 0, X is 70. And I'm gonna connect them with as straight a line as I can. And where will that be shaded? Under. So we got this little triangle right here. Okay. It really messes up my board, so I'm not gonna shade too much, but we're shaded right here. All right, now we're gonna do this equation. So I'm gonna cover up X. What would Y be? Solve that. I cover up X, so X is 0. What does that Y turn out to be? 50. So 0, 50. Now I'm gonna cover up Y. 150. Remember, I'm counting my tens. Here's 150, comma 0. Imagine that's a straight line. And where do I shade that one? Underneath. So once again, we've got a little area that's blue and red. And here are the corners of that area. So I'm gonna make a list. 0, 50, 0, 0, 70, 0, or this one. You're not gonna have to do this every time, but you're gonna have to do it a lot of the time. We're gonna have to substitute and eliminate to find that point. Okay? So, my red equation, 20x plus 60y equals 3,000. And my blue equation, x plus y equals 70. I need to know, where do those two things cross each other? take a minute and figure that out. You guys do the work, not me. What is their point of intersection? Substitute or eliminate. We got it? I got 30, 40.
Yeah.
Everybody else get that?
Yeah.
Alright. So remember, your X's are potatoes, potato acres, and the Y's are corn acres. Alright, so let's see where we get the most money. If I do that 30, 40 point, 150 times 30 plus 50 times 40, just plugging in 30, 40 right here. I got 6,500. So that's how much money I'll make if I do that. What if I put it all in corn? If I put all 50, or if I do 50 acres of corn and no potatoes, that's only gonna be $250, $2,500. Obviously, if I don't plant anything, I don't make anything, so that's my minimum. And what if I did it all 70 acres in potatoes? Wow. Everybody clear on where these numbers are coming from? All right, so what are you gonna tell the farmer? He should plant 70 acres of potatoes and no corn. For a profit of $10,500. So after you get done doing all that stuff, drawing pictures, shading, all that stuff, you're gonna write a sentence that answers the question. The question was, how much did he plant? How much will he make? And there it is. Yes.
When we're taking out our pairs at the very beginning, how do we know which ones to take out?
It is so when we did the shading, this is the area that was overlapped. It's the corners of the area that's overlapped. So as soon as you recognize this is what's blue and red, then the corners of that area are the ones you use. All right, one more. Oh my gosh, all the yarns. I even had a day off yesterday. roasted, whatever the heck that is. And total. Alright, have you filled in some stuff? Two cutting, 4 sewing for a knit suit. 4 cutting, 2 sewing for worsted. 20 hours a day for cutting. 16 for sewing. Profit on a knit is 34. On a worsted is 31. How do all those numbers look to you? Pretty straightforward. Getting in the chart. What am I maximizing? Profit. And how is my profit being calculated? $34 for every knit. Well, shoot, what am I gonna call knit? X. So 34 X's, I'll put it up here. Knit is my X's. Plus 31 Y's. That's how I'm gonna calculate my profit. Does that get graphed? No. What do I use that for? To plug my points into at the very end. So what's gonna get graphed? What's gonna get graphed are your constraints. Okay? So can you give me a constraint?
2x plus 4x is less than.
2x plus 4y is less than or equal to 20? You only have 20 hours. So 2x plus 4y is gonna have to be less than 20. What's another one?
4x plus 2y is less than.
And then of course we have our implied ones. X and Y are both positive, that's okay. We get that. Okay, here we go. I'll do this one in red. If I cover up X, what's Y?
5.
So 1, 2, 3, 4, 5, right there. 0, 5. If I cover up Y, X is 10. And I am shaded. And I'm here, right? Everybody keeping up? Alright, let's cover up X. Y is 8. Cover up Y, X is 4. And where's that shaded? Underneath again. So won't this is all shaded blue right here. So isn't my overlapping area this right here? Isn't that my overlapping area? So those are my points that I care about. So 0, 5. 0, 0, 4, 0, and something, right here. How do I find this something? Take my two equations. 2x plus 4y equals 20, and 4x plus 2y equals 16. I turn them into equals when I do this, because I'm just doing the lines now, not the shading. I mean, do whatever you do. I'm gonna eliminate. I got 2, 4. I'm gonna let you check that for me. Anybody else get 2, 4? Okay, so what's the next step?
2 right
We're not ready to write our sentence yet, we're gonna figure out which one's the best order. Plug them in. Where do I plug them in? My 4 points are all gonna get plugged in where? My maximization expression. Alright, so go ahead and plug them in. And tell me which point wins. And then write a short sentence to explain that, to tell the answer. Alright, what'd you come up with?
2.
What was your profit if you made no X's and 5 Y's?
155.
155? Obviously, if you don't make any suits, you don't make any money, that's your minimum. How about 4 X's?
136.
You say 136? And how about 2 and 4?
192.
196?
192.
192? Well, that makes it pretty clear then, doesn't it? What are we gonna tell this guy to do? The tailor should make,
2 knitted suits and 4 worsted suits.
exactly. The tailor should make 2 knit suits and 4 worsted suits for a profit of seems like a lot of work for $182, but that's what we're gonna tell him to do. Everybody okay with that? Okay. All right, we got a couple seconds or a couple minutes left. Not enough time to start another one of these. So let me give you another practice problem for our quiz tomorrow. And maybe someone can come up to the board and do it. It will be a Kramer's rule problem. So we are going to use Kramer's rule. And we're gonna solve 3x minus 8y equals 2, 5x plus 6y equals 1. There we go. Anybody wanna come up and do it? If you wanna use a marker from the box, that's great. I haven't touched those. So I've contaminated them. And we got 4 minutes now. No one, work on it. Good work, man. I only have one small thing to comment about on this problem. So first of all, everybody, the work there is great. They make the determinants look great. Everything looks great. Remember when we write our final answer, if, there are always gonna be fractions. If the fractions simplify, we should simplify it. So what about the 20 over 58? 10 over 29 would be a better way of doing that. So it comes out whatever it is, but then reduce it if you can. Okay? So 2 problems on Tuesday's quiz, along with our Pi Day celebration.